date has been rather dramatic. We have finished, since the last time we've talked, that we finished our complete panorama in full color and in stereoscopic views. So we actually have a topography now of the landscape around us, and Mark Lemon will be showing us examples from this wonderful product. We have a weather station that's operated for 65 sols. Vicki Hipkin is going to be talking about that and what we've learned from our polar weather station. And we are following the NASA guideline of looking for water on Mars, and we expected to find water in this landing site. That's why we came here. Odyssey discovered regional water supplies, but we're very pleased to see that we landed right on top of water ice, and the thrusters spread the soil away and revealed ice right underneath our lander. This was unexpected, and this was a wonderful thing for us because the water could have been all around us and not within reach of our robotic arm. We had no way of knowing on the local scale how the ice was distributed. So this has been a wonderful thing for us to be able to dig a trench, the Dodo Goldilocks trench, and find at 2 inches deep that there's a solid layer, and then to scrape pieces of this white solid layer off and watch them sublimate over the course of 4 days. So that was our first indication that this hard material is definitely ice. We have been now looking at the properties of the soil above ice. This is important for modeling this surface and trying to understand the interaction between the ice and the tiny amount of water vapor that's in the atmosphere. And we use a probe on the end of our robotic arm for trying to understand the physical properties of this soil, which are so important to our models. And that's what we've been doing for the last couple weeks. Plus, we've been looking with our microscope at samples of the soil. We see there's a clay-like component, in other words, very small flower-sized particles. And these particles have unexpected properties, as we found when we tried to scoop some up and deliver it to one of our prime instruments. And we are just getting to the point where we can apply another tool in our toolbox, the atomic force microscope, which takes our resolution down by a factor of 40 over the microscopic pictures that we have shown. And this microscope is just about ready to start its mission, and we'll be using this extended mission to do that sort of science. And so I ask for a little patience here as we get to the part of the mission where we do the scientific analysis of the soil in contact with ice. This does take some time, and we still have not collected all our data, so it's definitely going to take some time. And we are looking to understand the history of the ice by trying to figure out if this ice has ever melted, and through melting has created a liquid environment that modifies soils, changes chemistry, changes the microscopic appearance of these soils. And we're just getting the data back in the last week or two, and even, as you'll find out, very recently, yesterday. So this is an exciting time, and through this analysis we also hope to be able to answer a question that goes beyond just finding water ice, but is this a habitable zone on Mars? A habitable zone meaning that we have periodic liquid water, not today but over time, and we have the materials that are the basic ingredients for life forms. It'll be for a future mission to find if anybody's home in this environment, but we will be finding if this is a place that needs to be searched for life forms throughout the next 2 months of our approved mission. So far we've had 2 wet chemistry analyses completed. We see that the soils are alkaline. This is a mystery. We're on the edge of a volcano. This is typically an acidic environment. Certainly the 2 Mir rovers have found lots of evidence for sulfates and acidic environment. We find an alkaline environment here. Perhaps it has something to do with that nearby crater that impacted into this ice-rich soil and spread out a ejecta blanket that we are landed on top of. So that, I don't know for a fact, but that's a possibility. We are also finding nutrients, sodium, potassium, magnesium, chlorides. All of these things are things that we find in our own bodies and are definitely nutrients that are important for life. However, we have yet to discover organic materials. But the important thing is that we have used our snow white trench to try and get a sample of icy soil into our TIGA instrument. And First we did it by using the blade on our scoop to scrape down to the very hard materials where we could go no further, and then we have a scraper, and we've been using this scraper, and then finally a rasp. And I have a series of pictures to show this process that's taken place over the last month or so. So if I could see the first slide. This is the ground before we ever touched it with our scraper. Next slide, we did a simple 1 scoop wide trench. Next slide, please. Yes, and then the pile of the scrapings is behind it, or the digging is behind it, and it makes a little mound. And then we, next slide shows, I think we go to 2 scoops wide. So since we can't go any deeper, we have to go wider. There's 2 scoops wide, and to the left is a little scoop taken out. That was delivered to the mecha instrument. Let's keep going. Next slide. Look at this. At the bottom, we now see a dark patch after scraping, and that dark patch we consider to be ice. And it changes its properties over day by day. It goes kind of bluish, and then it goes whitish, and then it turns reddish. It's quite an amazing process as this ice sublimates away into the atmosphere. In other words, goes from solid to vapor without being liquid. Next slide. Shows further scraping on the soil, and the piles are getting bigger. Next slide. We extend the trench to be twice as long so that we can do the kind of activities in here we need to do to try and get samples of this icy soil. Next slide. There's a pattern. You see a 4x4 pattern of tiny little holes in the ice. This is caused by our rasp on the back of the scoop pressing against the ground and spinning out little cores of icy soil. And it's done in a beautiful way. The robotic arm team has just mastered using this tool, and they've made a 4x4 grid here, filled the scoop with about 3 cc's of icy soil. And next slide shows the latest, where we've scraped that material off the surface and actually successfully delivered it to TIGA. And to tell us about the TIGA sampling and what we're learning so far from the TIGA is the lead scientist on that instrument, Bill Boynton.
Thank you, Peter. Well, I'm very happy to announce that we've gotten an ice sample into the